Hello, this is an overview for section 4.7. In this section, we will take a look at optimization problems. Those are max-min problems, and we're going to first define maximums and minimum values. These max and min definitions are pretty much the same as the max and min definitions that we saw in Calculus 1, except this time we're going to be dealing with functions that have two variables. We're also going to define critical points. And since with two variables we have multiple partial derivatives, in this case we have two partial derivatives, we're going to set both partial derivatives equal to 0 and try to find those critical points, those x and y values that satisfy those equations. After we do that, we're going to run these critical values into a test. Now, unfortunately, our first derivative test from Calculus 1 isn't going to work very well. And so we're going to have to rely on the second derivative test. Our second derivative test theory transfers from single variable to at least two variables. And the second derivative test will rely on you trying to figure out a quantity called the discriminant. So the fxx, the fyy, those are second derivatives. And then you have an fxy and fyx. Those are the mixed second order partial derivatives, which we saw in a theorem a few sections back that they're supposed to be equal to each other. And so we get this fxy quantity squared to kind of represent the equality of those mixed order partials. Mixed second order partials. So anyways, when we have the discriminant, if the discriminant's bigger than 0, we have a possibility for a maximum and minimum. And if it's less than 0, we have a saddle. Now if it's equal to 0, the test is inconclusive, and so we had that same scenario back in Calculus 1, which is why we didn't use the second derivative so much. But just to reiterate the idea of maximums and minimums and saddle points, here's a picture that would kind of view these different scenarios. So the first picture on the left would be local minimums. The picture in the middle would be local maximums, and they are exactly what you would expect. Now the saddle point in our third picture gives you a different scenario now, where if you go, say, along the x or the y, you're going to have a derivative of 0, but then it's neither a maximum nor a minimum. In this case, it's what's called a saddle point. After we study these local extremas, local max and mins, we're going to take a look at absolute max and mins. And we're going to do this by looking at a closed set in your domain and finding out the local max and mins that's going to be within the set. Now it turns out that it's possible that on the boundary of this you might get your absolute max and mins. And so the extreme value theorem allows us or proves the fact that you're going to be guaranteed a maximum or a minimum if you have a closed set. And our procedure for doing this is to first find all the critical points, and then inside of your domain, and find all the critical points on the boundary of the domain, and decide which one of those would end up being your absolute max and absolute min. Okay, that is our overview for section 4.7. Good luck.